I'll quickly start sharing my screen. Just a quick confirmation that my screen is visible and am I audible?
Yes, to both.
Okay, thank you. Thank you. Good evening, everyone. So today I'll be sharing how we are navigating the ship in present day and time. Before that, a brief introduction about my company. Anglo-Eastern is the largest technical manager in the world right now. We manage about more than 650 vessels. We have about 28,000 professional seafarers who are carrying cargo safely from one port to another. And to assist this 28,000 seafarers, we have 1,700 shore employees in various locations all around the world. So I joined Sea in year 2002, and from that time till this time, our world has changed. This is the present traffic condition in the world. In year 2005, there were about 62,000 vessels in the world. And in 2019, this number has changed to 118,000. This data is from Equasis. And in year 2021, we have about more than 120,000 vessels registered in Equasis. So in past 15 years, the world traffic has doubled. And definitely the way we used to navigate ships in 15 years ago need to change. When I joined Sea in 2002, most of my friends always asked me that, can I navigate the vessel looking at the sun, stars, and moon? And my answer to them was theoretically yes. But when I took my first sight, that time, my position was almost about 250 miles off than my vessel's actual position. From the time I have joined Sea, I hardly use sextant or any other ancient means to determine the position of my vessel. But yes, we did verify the sextant with the land bearings and the ranges which are available to us. But these things are really ancient for us now, and we no longer rely on this. The voyage across two ports is still being called as a maritime adventure by insurers. More than 99% times, we do complete the voyage safely, but many a times this voyage is not completed and there have been accidents and incidents. I'm sure everyone would be familiar with the famous cases of Wakashio and Ever Given in our recent times. The objectives of the safe navigation never changed. So the objectives, when I learned them, were like to carry cargo safely from one place to another, which involved the vessel have a sense of direction. They know which direction they're going. The vessel should not touch bottom. So they need to have a sense of the position and the amount of water they have below keel. And the third principle was that the vessel should not collide with the other vessels or the buoys or the berth or any other shore object. That was more to do with the traffic management. So most of the technologies which developed during the time in past 15 years, they always focused on this. And also they utilized the artificial intelligence and the data which has been gathered by the technology. So let's embark on a sea voyage and see what all technologies and what all is possible today when we sail from one port to another and how navigation is conducted. The first and the foremost is the integrated bridge design. So presently, most of the ships which are built, they have an integrated bridge, which is designed considering a human and how humans are interacting with the technology in mind. What it means is that all the navigational equipments which you have on board are communicating with each other. They're interacting with each other and gives the information to the navigator in a very systematic manner. What I mean to say is that when I'm looking at a screen on a IGDIS or a radar, I really don't have to run around and go on my Navtex or any other equipment to see if there is any warning generated on there. So if my Navtex has any local area warning or any information, or if my AIS has sent me a message, or if there is a message which has come from a safety message which has come there, it will be readily available and displayed to me on my active screen. If there is a failure of any equipment or if there is an alarm, the same alarm can be displayed on my screen, on the navigational screen, and I can acknowledge that alarm from there. So once I have all the information at one place, it improves the navigator's situational awareness and the decision-making process. Most of our vessels are equipped with this integrated bridge solutions now. Again, so the second thing which artificial intelligence and the big data has introduced us recently is automatic route planning and optimization. When I was second officer, normally whenever we got voyage orders, and the key things which we were looking for is the name of two ports, and then we will start looking into various publication routing charts and ocean passages of the world to find the most favorable routes between these two ports. Once I have that information, I will go and look in the weather forecast and then see what would be the most optimized route for this tour. Or otherwise, I will wait for my weather routing companies to give me a solution or a route for which I will need to wait another 3-4 hours before I can give an approximate distance to the master or an approximate like a requisition of the charts in the publication which will be required for the voyage. But with the advent of technology, this has changed now. So presently, the softwares and the technology which we use on the ships, it requires the input of the two ports where you want to sail. And you will need to put in the settings, the basic settings of the vessel, like what is the size of your ship, what is the draft, what is the minimum distance you want to keep off the dangers, and how much water you want to keep below keel. And the automatic route planner will give you a route. Same time, this automatic route planner will optimize this route for the weather parameters which you're fed in. For suppose you don't want to face a wind force of 6 or a swell of more than 4 meters or 5 meters, the tool has the ability to plan your course away from such forecast areas. Important thing is that for a mariner, for a second officer, or for a navigating officer, the task which needed about 6 hours to finish is completed in about 30 minutes. What I mean to say is that the route, the optimization, downloading the charts by click of a button right now. Once your route has been planned and you have done the checks, you can put this route in the monitoring mode. When the route is on the monitoring mode and the vessel is out at the sea, the navigator in his watch needs to ensure the vessel is following that route. And second, he has to be careful about the traffic conditions. So he has to focus more on the lookout and the vessel is following the route. As soon as the route has been put on the monitoring mode, it is taken over by the track control system. The track control system will adjust the course of the vessel and take care of the effect of the current and the wind. So they will keep the vessel on the track which has been put on the monitoring mode. They also have ability to control the propulsion system. So what I mean is that they will automatically reduce the speed of the vessel in case needed to arrive at a destination at the defined time. So the mariner can focus more on how the technology is working rather than, going and taking over the hand steering or doing the course alteration by himself. Another primary role of the mariner when they are at the sea is lookout. So basically a collision avoidance. In earlier times, the mariner would take use of radar and AIS and visual lookouts to identify any targets. Once they know that there's a target, then they will have to wait a certain amount of time before they can identify what it is. Is it a buoy or a fishing boat? Is it sailing? They need to go and acquire that target in the radar. Many times, people really do not even know what kind of, like, is it a fishing buoy or a port hand buoy or an isolated danger mark. So presently, one of our vessels is fitted with this technology where they have camera sensors which transform the information which is being looked from the camera into data. So the camera sensors are connected with your AIS. It is also connected with your ECDIS. And this information is transferred to a screen where the identification is also easier. So this is a real view of a vessel approaching Ulsan. And once the camera sensors identify the vessel, it will give you the distance, the range, and the bearing, if there is any risk of collision. If there is a buoy or an isolated danger mark on the ECDIS and the camera sensor can view it, this information will also be displayed here. So again, this technology assists the seafarer in identifying the targets as soon as possible, and if there is any necessary action which has been designed. So in case there is a risk of collision with the vessel, so another thing which is readily available nowadays is the automated collision avoidance. So what happens with this tool is that this tool will read all the vessels or the stationary objects and give you the best possible solution or the best possible maneuver which the vessel will need to carry out to ensure the safety of the ship. It takes into account the charted depths, shallows, danger to the navigation, and it also gives suggestions in case if you want to reduce the speed on the engines. It will automatically calculate how much course alteration is needed or how much speed reduction is needed. In case if an emergency maneuver is required, that will also be displayed in the system. As the vessel has departed and it reaches in the port area, the VTIS also have the same kind of monitoring tools. They generate automatic alerts in case of any dangerous situation is being developed. In case of any collision situation or a dangerous situation is being developing between the two vessels, or if the vessel is, passing very close to the shallows or it's going close to the danger mark, the VTIS will be automatically alerted and they can come back to the vessel and request a corrective action. Once the vessel reaches the pilot point or approaches or the breakwater, the automatic maneuvering solution advises the vessel what kind of maneuver is required right now. So they calculate the distance to the breakwater, to the jetty, to the locks, and they would be automatically giving the suggestions to the user. Like if they want to go half ahead on the engines, dead slow on the engines, want to give rudder hard starboard or rudder to starboard 30. So these kind of suggestions will come from the system. Additionally, if the system is connected to the propulsion system of the vessel, like the bow thrusters and the propeller, the entire control of the propulsion and the maneuvering is given to a joystick, and the vessel master can use that joystick to navigate the ship. This system also predicts the vessel position in next 6 or 12 minutes. So the user and the navigating officers can see if they continue proceeding in the way they are proceeding, where they will land up in another 6 minutes or 15 minutes of time. It again improves the decision making on board in case if the vessel is not following the track or if it's going to land in a dangerous situation, immediate corrective action can be taken on board. And actually this whole system about the smart docking is also automated. So the user can actually take control of it, or it can let the system decide it for itself. The smart docking system is also based on the laser sensors and the camera sensors. So it have an accuracy of almost about 0.5 meters. And once the vessel is coming close to the berth, it will give you distances off the berth. and helps in the parallel parking of the ship. It's exactly like how we have automated cars and how we park the cars now. Similar tools are available for the pilots and for the mariners in case of redundancy. So you have a tool, something called a solution, a go home safe solution, where in case if there is any failure on the bridge, if your egg dish is not working, or if you don't have the availability of the backup egg dish as well, the information is available on an application. So you can easily download that application on the iPad or any other device, a Windows device, or even on a phone. And you can use that application to navigate your vessel to the safety. Besides all these tools which are available on ship, I would like to let you know that the vessel are being monitored by our Fleet Operations Center 24/7. So these ships are watched by a Fleet Operations Center. And in case of any deviation from the planned maneuver, or in case of there's any alert, the Fleet Operations Center will alert the vessel and get in discussions with them, and possibly suggest them any corrective actions which are required. Besides that, in year 2017, Wärtsilä has already tested the remote control of a vessel when the vessel was at sea. So the vessel was about 8,000 kilometers from the land, and a command was sent from the shore center to the propulsion system, which was successfully executed as well. Also, the remote control assistance allows the vessel to be successfully diagnosed for the troubles, and it can be used for troubleshooting as well. In case of any troubleshooting in any of the equipments like the egg dish, radar, NAVTEX, or GMDSs, these systems are connected from the shore. The technician can connect to them and provide the support to the ship as well. There is one thing which we need to always remember, that technology only gets adopted if it saves money for the existing businesses or creates model for the new businesses. In case the technology is not profitable, it is very hard that clients and the users will accept it. There are certain challenges in adopting these technologies, which is the reliability of the sensors. Marine environment, as we all know, is very harsh. We face bad seas, constant vibration, rolling, pitching, yawing. We really are not sure that if all the sensors which are provided by the suppliers are durable enough and they would withstand the harsh conditions of the maritime world. So it is very important that the sensors which are available on the bridge and also in the engine room, which are monitoring all the data coming from the ship, they must be of the industry standards. So there are certain ISO standards which are applicable to these sensors. So any sensors which are being used on the ship should be certified to these standards. The second important thing is data connectivity. So presently, if we using the sensors and we are getting all this data from the ships can generate about 50 to 100 GB of data every day. Our home connections, maximum speed we get is about 4 Gbps. And the shipboard VSAT, the maximum speed which we are getting is about 2 Mbps. And many ships with a VSAT are just buying a 30 GB data package. So this is also a challenge which we need to look into. Cybersecurity. All the systems which are available on board are connected with the shore. Are the systems secure enough? Do you think they can be hacked? So it is very important the service provider or the company and the mariners understand the cybersecurity part of it They should be aware when the system can be hacked and what all precautions they need to take to safeguard the systems. Presently, all the navigation is regulated by SOLAS, STCW, and the call regs. In case of so much automation coming in the industry, the regulatory framework also needs to change. Also, the mindset of the people. Many times we meet certain clients and certain stakeholders who do not even believe in having two EGDIS on board. So their primary means of navigation is EGDIS, and still they want to keep backup as paper charts. So mindset of the people also needs to change. And people should be more open in adopting the new technologies which are available. Important thing is all these technologies which are designed, they're designed for humans, and humans are the one who will be using these technologies. So we need to focus on the training. One very important thing which needs to change is the training of the people. So instead of having the legacy training systems, training needs, and teaching them more on the theory, I think the training should shift the focus on the competencies which will be required in the future, such as people should be able to understand the data, get the insight, and should be able to take action after getting the insight from the data. They should be able to recognize the limitations of the automation, should be able to process large amount of data which is coming from this automation system. They should be able to focus on the critical issues, should be able to change rapidly, should be able to communicate effectively, should be able to work with the remote teams. Right now, I think in the times of COVID, everyone has learned that. And always have open mind about ability to learn continuously. More changes coming. There would be more smarter ships, there would be autonomous systems, there would be advanced radar and propeller system, robotics coming into navigation as well. More big data and analysis which is coming. The big question which we need to ask all the navigators is that how far are we from no crew on board seagoing vessels? Personally, I feel that we have all the tools and the technology available. We just need to focus on the training and the regulatory framework. And I think in about 20 or 30 years, we will have seagoing vessels with no crew on board. And I would leave you with that question and a thought that what else is possible with the navigation and how technology can be more helpful to the seafarers. Thank you very much for listening to me, and I'll go back to the host.
Thank you so much, Captain Ohar. You have actually ended on a very interesting note, because when I first went to sea, it was just the beginning of unmanned machinery spaces. And at that time, that in itself was a very novel outcome. We just loved the idea of not having to go and spend the night on watch, whilst the deck officers went and had to still keep watch on the bridge. So I think now you guys have kind of taken over and said that, it's not just the machinery spaces, we will take away people from the navigation spaces as well. I think you covered the whole aspect of navigation from historic times to the current and the future. There are a few questions, and I would just like to begin with Captain K. Vivekanand, who has asked that almost all sophisticated equipment on the bridge are GPS dependent. So what happens in the possible scenario of GPS failure, which is a possibility?
Yes, that is true. We have cases where we have seen GPS failure or erratic readings and GPS spoofing as well. I can tell you what we are doing about it. So in our company, we have two systems, two independent systems. So we use GPS and GLONASS, where the information from the equipment and the feed is given by two independent satellite systems. So GLONASS is a Russian-based satellite system, and the GPS is American-based. So presently, we are using this control as mitigating means. Most probably, when we have in the future, I know that very soon we will have your low orbiting satellites as well, which is coming from Elon Musk. And definitely we will have more technologies and interesting things to see when that would be available to maritime world.
Okay, that's great. For those who have questions, could you please add them on to the Q&A section so that we can pick it up from there. A couple of other questions, one relating to cybersecurity. You mentioned that today with some ransomware incidents and the vessels being connected to shore networks more frequently with larger number of systems, how do you reckon that companies should deal with this scenario, and how effective will these be?
So I would just let you know that we have our EGDIS. Many of our EGDIS are online right now. Besides EGDIS, there are a few other equipments also which is online. So one important thing, as a mariner, I don't understand a lot of this cybersecurity, but what we know is that the protocol from the service provider which we have is set. So the system is not allowed to communicate anything other than that fixed channel which is given to the equipment. So in case of any remote support or anything which is there, so that channel and that is only available to our service provider. So it is not that anyone can connect to that system. And also, like there are certain tests and the quality controls with the system, the cloud has to pass before it is being given a cyber secure certificate. And as a company, we just need to check that. So if we are taking services from the vendor, we have to make sure that they are ISO certified and they have all the cybersecurity protocols in place.
Yeah.
As a mariner, master mariner, all I need to do is that before I give access to any shore personnel, I need to make sure that I'm giving access to the right person.
Okay, this is a question from Anil Tyagi asking, are you doing any specific preparation for autonomous shipping?
The answer to this is no. We are involved in very small, as a whole, we are not involved in any project, but as a small sectors, like we are also involved with IMO and all these companies like Wärtsilä, where we are looking after like small parts of the autonomous shipping, wherein I believe that these small links will combine together to form an autonomous ship.
Right. Thank you. You mentioned briefly about training. Today's modern bridge, is kind of bristling with monitors, electronics, and all kinds of equipment that make it look like probably a command center for a rocket launch, literally. How much has of this, I mean, in terms of training, do you think has changed from the days of the sextant and the basic GPS or radar to allow officers on board to be more competitive and to feel more comfortable in dealing with these equipment, and also to utilize them to their key efficiency? It's like Microsoft Word. I know 2% of it, and it can do 100 other things that I don't know. So, in terms of training, how do you see the transformation and the shift, and what's the roadmap? How do you think the future will be for a deck officer?
So our training philosophy at Anglo Eastern is that we try to train everyone on a very realistic scenario, like what they will be facing and looking on the ship. We have full mission simulators, and we kind of replicate exactly an integrated bridge on our simulators. When we train all the officers, which we go before they go on board, so we make sure that they have to pass the simulator test, and most probably, like, it's more on the hands-on training. We do not, as a company, do not still believe in sextants, so there is very less theoretical approach towards that. And also, one very important thing is with the advent of the technology, and which also we are using, is that the real scenarios from on board ship, like a ship approaching Singapore Strait and Shanghai, or all these areas, can now be exported directly to our simulator systems as well. So whatever is a real scenario, so we do that in many cases, in case of real emergencies or real near miss, or in case of any accident, we pull out all the data which was there on ship and that live situation, and we simulate that exact condition on our 360 simulators. So when our officers come in the training center, they really get to see what was that situation.
Right. Thank you. You had mentioned also about augmented reality and a lot of decision support or decision making information being given to the navigation officer on board. Now, would these lead to complacency or an erosion in the basic navigation skills, which will mean that our dependency on these systems would increase, to a level where we will not be able to do without them?
Yes, I agree, but I think the complacency has, honestly, we believe that complacency has no cure. And the only thing is that you can train people how to use technology to their advantage. And also you need to assess and monitor them when they come to the training center, and also onboard assessments. Whenever we have someone from like a master would be assessing a second officer or chief officer. So we try to make sure that assessments on board is also very real, is done on a real scenarios. So once you have that all process set in, we hardly see there is any role for complacency. Also, one very important thing is with the cameras on bridge and with the shore team monitoring the vessel all the time. Once people know that they are being watched and monitored, the factor of complacency also reduces.
Okay. Thank you so much. There's one last question that we'll take today. It's maneuverability is a matter of concern in certain scenarios. Do you think simulator on board would help navigators in improving the ship handling of that specific vessel?
I completely agree with that. But again, it is a very commercial dependent solution. Like, I am not 100% sure how many owners or how many clients would agree to that.
Correct.
So presently, what we do in Anglo Eastern is that we have very specific models. Again, it's a very real-time models which we take from the ships which we have in the management, and we use such models in generating the exercise on shore.
Okay. Thank you so much, Captain Nohar. That was a very insightful sharing, and I think I'm a better deck officer today since I began in this industry. Look forward to catching up with you in person in the near future. All right.
Thank you so much. Thank you for hearing me. It was a great pleasure. Thank you.